So welcome everyone. This is, I believe, the fifth webinar in our DRI webinar series. So back in February, we started Digital Research Infrastructure webinar series to look at infrastructure projects and communities in the UK and beyond, and see what kind of initiatives they run and learn more about those. And these sessions, slides aren't working, they are. So a little bit about us, if you don't know, Digital Curation Centre, we were established in 2004. We are based in Scotland, Edinburgh. We're part of University of Edinburgh and University of Glasgow, and we offer various services and products. Some of them you can see here on the slides. Our annual event, International Digital Curation Conference, as well as our DMP writing tool, DMP Online. And we also ran International Journal of Digital Curation, amongst other offerings of training, consultancy, and guidance. So I think we're going to start today with a quick book lab question. I hope that this works, because with technology, I feel like there's 50-50 chance this might not. And it is not working. It is working. Okay, so if I could ask you all, why is it running ahead? So if you can scan the QR code with your mobile devices, or go to the website wooklab.com and add the event code, which you can see on that on the top right corner, then I can see one person join. So something's working and people can join, which is brilliant. I'm gonna let at least half of you get on, and then we can move on to our questions for today. Okay. Struggling. Let's move. Well, there we go. So perfect. Thank you for the thumbs up. So the first question is, what country are you calling in from? So where you're based at? I'm from Scotland, based in Scotland, Scottish borders. Not far from us, we had snow yesterday, so I'm kind of enjoying a little bit of sunshine today. And yes, Scotland and UK well represented today. Northern Ireland, well done. Do we have anybody from Wales? Can we get the full representation? As I mentioned, this is recorded, so I know that a lot of people tune in afterwards. So I'm sure the representation will be wider. Can you also share with me what's your job title, just to see kind of what places we're at with that? As I said, I work for Digital Curation Centre, and I'm officially the events specialist there. But I would assume that not many event specialists are here on this call today. Project coordinator, research analyst, perfect, research data manager. Okay, and moving on, I believe we have research analyst. I think we have another question. Yes, so as I said, we have our guest speakers today, Alison, Pamment from the National Centre for Environmental Data Analysis, and Pritchard from JASMIN. So a question is, argue with the organizations and the work they do. And we can see a little bit or not at all. And very familiar. Am I guessing right that it's one of the speakers who's a very familiar response? Possibly. But yeah, so this is perfect place for you if you're just a little bit or not at all familiar to learn more about what they do. And finally, And no, that will be after. We're going to stop here with 3 questions. That's plenty. And I'm going to move on and pass it to Alison. If you want to share your screen, and you can see hopefully that the rest of the webinar goes on without any issues.
Thank you. Okay, so hi everyone. So yes, my name is Alison Pamment, and the title of our presentation this afternoon is Getting to Know CEDA and JASMIN. So Matt and I will be sharing the time roughly equally between us. So I will speak to you for about 20 minutes about CEDA and then pass over to Matt to talk to you about JASMIN. Just get this to advance. Okay, so starting with CEDA then. So who are we and what do we do? So CEDA, as the acronym is explained there, is the Centre for Environmental Data Analysis. But what does that mean? So our mission statement is there at the top of the screen. So it's to deliver innovative atmospheric and Earth observation data services for the benefit of science and society. So quite a lofty aim, I think. And there are 2 main planks to that. So the first of these is the CEDA archive. So it's there on the side EDS, that's the Environmental Data Service. I'll say a little bit more about that in a moment. But we are a long-term archive for atmospheric and satellite Earth observation data. And the other plank of what we do is providing the JASMIN data-intensive supercomputer, which Matt will be speaking to you about later on. The photograph there, incidentally, it shows most of the current CEDA staff. That was taken about 18 months ago at CEDA's 30th birthday party. We're a group of about 30 plus people, so about 30 regular staff members, and then we also have people coming to us on apprenticeships, for example, software engineering apprenticeships and year-in industry students. So the numbers go up and down a little bit, but about 30 people who are regular members of CEDA staff. So just to explain a bit about where we sit organisationally. So in the bottom box there in the centre of the screen, you can see CEDA. So I've already mentioned the archive and JASMIN, and that other box says we spend a lot of time developing new things. So that's where the services and the technology come in. But in terms of where we actually sit organisationally, so we are part of one of the UK research councils. We are in the Science and Technology Facilities Council, STFC. And we sit actually in the RAL Space Department. I think the connection there is the satellite data side of things. We also work closely with the STFC Scientific Computing Department. Some of their staff work very closely on JASMIN, so helping to keep the actual computing infrastructure running, but effectively doing the system management of JASMIN. And so they're a very important part of what we do. But then a lot of the funding for our work, because we're an environmental data centre, comes from another of the research councils. So that's the Natural Environment Research Council, via 2 of their designated research centres. So there's NCAS, the National Centre for Atmospheric Science, and NCEO, the National Centre for Earth Observation. And among our data scientists, we have people who are domain specialists in both those areas. And CEDA itself is part of the NERC Environmental Data Service, and I'll say a little bit more about that now. So besides CEDA, NERC, via its research centres, funds a network of environmental data centres, each concentrating on a different scientific discipline. So I've already explained about CEDA, but in addition to ourselves, there's the British Oceanographic Data Centre, who deal, not surprisingly, with marine science. There's the EIDC, the Environmental Information Data Centre, and their area is terrestrial and freshwater ecology. And then there's National Geoscience Data Centre, so they're attached to the British Geological Survey, and the UK Polar Data Centre, which is part of the British Antarctic Survey. And so jointly together, we form the NERC Environmental Data Service. And our role across the data service, whichever of the data centres you are communicating with, our role is to support and advise on all aspects of data management, including preparing data to be archived and data submission, data management planning, which is very important, And then it's our responsibility to curate that research data, make it freely available to anyone who may have an interest in reusing it for any purpose. And that may include people who are doing research for commercial reasons. They can have access to our data as well. So we don't provide operational data to commercial organisations, but if they're looking for some research data, they can certainly use our data holdings. And on the slide there, you can see this thing called the Core Trust Seal. So this is kind of an industry standard, if you like, for trusted data centres. It's peer reviewed, and all the NERC environmental data centres are currently holders of the Core Trust Seal. So we reapply for that every 3 years, and CEDA and all the other data centres are currently holders of that. So moving now to talk a bit more about the CEDA archive itself. So at the centre of that, there's the actual, if you like, disk storage and tape storage, which is where the data live. And we do a lot of data management to manage that storage space. And key to that, we have to be able to both ingest data and get it into the archive and provide access to our users. But to do that, there's a whole bunch of other activities that go on. So some of the data ingest is done through direct contact. So our data scientists will communicate directly with individual data producers, often on NERC-funded programs, and help them to prepare their data for archiving. We are also a place where other EDS data centers can deposit large data sets because of the large amount of storage that we have provided through the JASMIN infrastructure. So although the data will be catalogued through the other data centers and accessed via their services, it actually physically is stored on the same infrastructure as the CEDA archive. And then on the user access side, we provide, as I say, data catalogues. We provide that in various forms, and we provide other services. So something called the Earth System Grid Federation, ESGF, that's for providing access to climate model data. The EO Data Hub, Earth Observation Data Hub, is a way of joining together academic and also private industry produced Earth observation data and providing a common point of access to that. So there are many services built on top of the data itself. And then in order to facilitate all of that, we also run training courses, and we work with other people in the research data community to develop data standards and so on. So there's a lot of activity goes behind the parts of it that people externally see. So within the CEDA archive, so as you can see here, we've got about 30 plus petabytes. Some of that is stored on tape. A lot of it is also on disk, but we can't keep it all on disk. So some of it, for example, the Sentinel data, which you'll see is almost half the data holdings, over 17 petabytes. So this is European Space Agency Earth observation data, monitoring satellites for land, sea and atmospheric conditions. So most of that is actually stored on tape, but people can still access that. I won't go through all of the things pointed out on the slide, but another one to point out is in the green section down here, that's CMIP, that's coupled to model intercomparison project data. We've got over 5 petabytes of that. So this is climate model simulations, which are then fed into some of the big reports that come out every few years from the International Panel for Climate Change. And these are the model data that are behind those reports that talk about the state of the climate and climate projections for the coming century. And then we have a lot of other smaller data sets, heterogeneous ones. So we have some Met Office data, for example, data from the European Centre for Medium Range Weather Forecasts, and also things like Royal Navy ships logbooks going back to the 18th century, aircraft data. So it's really quite heterogeneous in terms of the subject area that it covers. This is some information taken from the 2024-25 CEDA annual report, just looking at who uses our data and how many people access it. So in 2024-25, we had access to our data almost 140 million times. Some of that was downloaded, so nearly 2 petabytes of downloads. A lot of the data, however, is accessed now directly on the JASMIN infrastructure, which removes the necessity for people downloading the data to their local institutions. That's a much more efficient way often of accessing the data. So we have 330 active NERC projects. So that will be people providing data to us for placing in the archive, or possibly people wanting to access the data, use it on JASMIN to work on it within their own projects. And you can see also some statistics about large numbers of files and data sets being published. What's interesting to note, though, if you look at the pie chart on the left, although a lot of our users are interested in things like climate change and Earth observation, atmospheric physics, we have really quite a diverse user base. So other scientific disciplines such as engineering, maths and computing sciences, but also people coming along to use it for personal use as well. So really a wide range of users come to our archive. Get the slide to advance. There we are. So what do our data scientists do on a day-to-day basis? Well, we have this important idea of research data life cycle. So this is something where you start with data being created initially from a project, and then being analysed and actively managed as the data are collected during the project lifetime, then being prepared for archiving in a long-term archive such as CEDA. And eventually we can create DOIs for that data and publish it, so you can link to it from a published paper, for example. And then we also create data catalogues and registries so that other people can come along and reuse that data. Maybe it will be fed into other projects, which will then cause further data to be created and so on. So it will go around the data life cycle. So our data scientists are active throughout most of that research data lifecycle and can provide support and advice on many of the activities in there. In particular, one of the things that we do help with is for people who have got NERC grant funding to produce environmental data. We help them with data management planning. This is something that has to be done at the very start of a project, so it's part of the conditions of the grant. So the principal investigator has to create a data management plan talking about which data the project will likely to be creating, what the data volumes are, the kinds of formats it will be in, whether all of that data is suitable for long-term archiving or some of it may not be, and also sometimes talking about which EDS data center they should archive their data, because if it's multidisciplinary, you may want to archive things in more than one place. And so there are all these sorts of questions, and in order to assist with that, we use something called the Fair Data Stewardship Wizard, which is a cloud-based tool. So it's a questionnaire, and we don't ask the PIs to go through this on their own. This is done with the support of a data scientist who's assigned to that project, but it helps in saving time and energy in the data management planning. Crucially, it ensures that the plan exists from the start of the project. It can be kept up to date. It's in machine readable format, and it's standardized form across all the data centers, which helps with collaborative working if the data are held in more than one place. And it's a living document, so it can be updated throughout the lifetime of a project. So that's one of the very important functions that we do. I mentioned that we have particular file formats. So this is just a list. There's a link there to a help article on the CEDA website if you want more information about this. But we support a number of formats. Our most preferred one, particularly for atmospheric data, is something called CF NetCDF. So that is NetCDF, which is a binary file format for large data sets, often multi-dimensional data sets. So geolocated data with latitude, longitude, height, and then time, and so on. So this is multi-dimensional data, often on latitude, longitude grids, but it could be on a different kind of map projection. And CF metadata, that stands for Climate and Forecast Conventions, which is something that we actively support at CEDA. And those two things together go to make CF NetCDF, which is one of our preferred formats. But we'll also accept other formats, so HDF. GRIB and PP are both binary formats often used for numerical model atmospheric data. We take a number of text formats, comma separated values. So something called BADC, CSV, and NASA AIMS are both essentially for spreadsheet data. HITRAN there, that's for spectroscopic data. That's a more specialist kind of data format. And we also take image data. A lot of the Earth observation data comes to us as images, so things like GeoTIFF and JPEG 2000. So if somebody wants to deposit data with us, we would certainly encourage them to use one of these formats, and we can help people to get their data into the correct format, provide the correct metadata ready for archiving. And the aim always is to, as I mentioned before, I think to make our data fair, which is findable, accessible, interoperable and reusable. That's really the watchword of what we're trying to do. And then once data have been ingested into the archive, we have a catalogue. The address is there at the top of the window, and so you can search that with the search term. So here I just typed in precipitation and it came back with over 2,000 results for that. But you can obviously refine that search a bit and see what data sets we hold, and the links will take you to places where you can actually download that data or have other methods of accessing it. I mentioned also one of our activities is training and skills development. So we run a number of training courses from CEDA. So we run something called the Introduction to Scientific Computing course, which runs every November at the University of Leeds. And that's using software carpentry materials to introduce things like Linux, Python programming and so on. We also run about 3 or 4 times a year JASMIN beginners workshops for people who've got accounts on JASMIN and are new to the system, just to help them get orientated. And recently we've also started, as part of the EDS, running some data management training. So looking at principles of things like data management, planning, archiving, publishing your data, getting DOIs for it, and so on. So I don't want to run on too long because I don't want to steal from Matt's time, but just to mention a couple of projects that we've been working on recently. So I mentioned climate model data. Currently there is another phase of the CMIP project taking place, and we will be archiving some of the data from CMIP 7 as it's known. And we've also put a lot of work into the background planning of that, because this is a huge international project. When you've got large groups of people around the world, climate modelers producing large amounts of data, there has to be a lot of planning going into that to produce a coordinated response to be able to archive that data and make it available in a coordinated way. And also something that we've worked on recently, we've had some UK government funding to develop something called the EO Data Hub. I mentioned this earlier. So this is, I think we've now gained some additional funding to develop this a little further. So this is taking data from academia, government and business, and combining data sets with a single point of access, which hasn't really been possible before. I won't say any more now. I think I'm probably out of time. And so my plan is to stop speaking now and hand over to Matt to talk about JASMIN. I think Matt wanted me to continue sharing the slides.
Thanks, Alison. Yeah, if you're happy to do that, yeah, then I'll just ask you to advance the slides each time. So yeah, next slide, please. So yeah, thanks for the opportunity to talk here, and thanks to Alison for her introduction to CEDA. So JASMIN is essentially the UK's data analysis platform for environmental science. So I'm going to give a bit of an overview of what it is. Next slide, please. Starting with a bit of history. So it's actually quite good we've done it this way round, because you've understood a little bit, hopefully, about what CEDA is about and how it's come together and what it does. And so a little bit of history. We've talked about CEDA existing for 30 years and the celebration that we had a little while ago. In fact, it existed as 2 differently named entities, the British Atmospheric Data Centre and the NERC Earth Observation Data Centre, from the sort of late 90s, early 2000s. And that grew and grew as various data sets became curated in those archives. Each of those a designated NERC data centre. But eventually things got to the size, both the data sets and the sort of infrastructure needed to host it all. Kind of the CEDA archive, which sort of really came into being around sort of 2006-07, was sort of outgrowing its hosting environment, and also just what how people wanted to interact with the data was changing as well. So with the size of the data sets and the complexity of the workflows that people wanted to do, the need to just download the data, well, the ability to just download the data and process it at your home institution wasn't really enough. What we really needed, or what the community needed, was a place to be able to do those computing activities, the data analysis work, in the same place as the data, and hence Jasmine. So we really wanted to avoid the need to move these large and complex data sets around, but also to enable some collaboration around those data. One of the things that's been really interesting to watch as Jasmine has grown is how communities have grown up around particular projects and data sets, and it's really been a platform to facilitate that collaboration. But the service itself aims to kind of provide a balance between the flexibility to allow people to work in the ways they want to, but also to provide the performance that they need to do that data analysis, particularly at scale with the size of the data sets that particularly climate scientists and earth observation scientists, and those two working together increasingly. Next slide, please. So I know Alison's touched on this already, but a little bit more just sort of focused on Jasmine. So Jasmine is a NERC-funded facility, but it's operated by STFC. Within STFC, we then have two teams who support it in the background. So I'm part of the team within the Centre for Environmental Data Analysis in RAL Space, and we run the user-facing side of Jasmine. But our colleagues in scientific computing work on the same site just across the road from us. They look after all the hardware, the racks, the network, and all the bits of infrastructure that support Jasmine. But really together we've developed the architecture of Jasmine, and we continue to do the sort of digital research infrastructure engineering that's needed to sort of develop and maintain Jasmine to support not only the services for CEDA, but also Jasmine's own user services, which I'll talk a little bit about. So the end result really is, it's a hosting environment for the CEDA archive and its own services, but a co-located HPC-powered data analysis platform, and both of those things supported by specialist teams. Next slide. So this diagram, it probably goes into too much detail, as does the rest of the stuff I'll show you, but it's to give you a flavour of what Jasmine is about and the sort of things we provide. So down the left-hand side, we've got a bunch of services, information services really. So documentation, training, dashboards about how the system is performing, status board with incidents and status of those and things. But on the right-hand side, we've got various layers in the system. So right at the top, we've got some sort of management and external access services. So for example, there's an accounts portal where you can manage your Jasmine account. You can use the projects portal to apply for resources for your project if you're a project PI. Then you would use one of the login nodes, or the NX login is like a graphical Linux desktop thing. You can use either of those to get sort of onto the Jasmine platform, and then primarily use one of the services in the orange layer in the middle. So there's a common stack of software that we maintain across the different types of compute services that we provide. And those comprise some interactive machines. So we call these SCI machines, or scientific analysis servers. And alongside those, we have a sort of a batch cluster, which we call Lotus, which is a 55,000 core CPU cluster managed by a scheduler called Slurm, and a modest sized GPU cluster alongside that for some of the kind of AI machine learning type of development that people are wanting to do these days. So all that is supported by the storage services that you can see underneath there. So I would consider the CEDA archive to be just one of those sort of storage services that Jasmine provides. The other ones, for example, like your home directories, or GWS is group workspaces. Then we've got XFC is transfer cache. which is kind of similar to Scratch storage. Scratch is really sort of intermediate working storage that you would use while you're using the batch compute system. Transfer cache is really sort of large temporary space that you can use during the task of some large data transfer activities. So you might bring some data in, manipulate it, and decide to discard some but keep other bits of what you've moved, that sort of thing. So those are the storage services, and then supporting those, we've got a range of different storage media, which I'll say a little bit about later on. On the right-hand side, we've then also got what we call the JASMIN Cloud, with its own management portal and a sort of feature called CAS, or Cluster as a Service, which is essentially a set of building blocks that allows a tenant project to construct its own bespoke computing infrastructure. So you could create a mini batch compute cluster, or some outward-facing web services, or some specific analysis machines. Basically, something that isn't necessarily supported by the managed infrastructure that you see on the left-hand side. Down in the bottom corner, we've also got what's called the data transfer zone, which is something that we have developed along the lines of a blueprint developed by the Energy Services Network in the US, and with our colleagues at JISC, who run the JANET network for academic institutions in the UK. And this sort of builds on some of the best principles of developing a set of sort of architectures and policies that enable friction-free transfers to happen as in a performant way as possible. So we can, with that sort of added onto the side of Jasmine, we can facilitate the large and high performance data transfers that people need to do to get data sets in and out of Jasmine as efficiently as possible. I think that's probably enough on that diagram, so let's move on. Thanks. So this just gives you a flavour of the size of Jasmine at the current time. So roughly 2,500 users and about 400 odd tenant projects of different types, spanning the whole range of environmental science, really. We consume quite a lot of power. That's something we're very conscious of, and we have some activities aimed at addressing that, which are taking effect already. I mentioned the STFC, the Jasmine Cloud. So there's about 30 odd, 35 tenancies within that cloud infrastructure. And then, yeah, I mentioned the size of the CPU cluster already. But we also provide those 8 or so interactive Sci machines. They're the scientific analysis servers where you can log in and sort of do work interactively. Then on the storage, just to give you a flavour of the scale of what we've got there. So several petabytes really of space for both the group workspaces, which is the sort of volatile project working space, but also for the CEDA archive. And that's roughly split half and half between those two, with a bit of extra you can see there for Scratch and transfer cache and other things. But also alongside that, we've got the tape capacity, which is used for primarily for a backup of the CEDA archive. There's actually a dual backup of that. So one copy is kept in the tape library, another copy is shipped off site somewhere. But on the Jasmine, for the Jasmine group workspaces, they're not systematically backed up there, but we provide the tools and the capacity for projects to store nearline those data that don't need to be online all the time. And there's some other types of storage there which fit particular purposes as well. And so let's move on. Next slide, please.
Just a moment, I'm having a bit of trouble advancing.
Okay, great. So just to illustrate some different ways of using Jasmine. So on the left there, we've got managing your account in the accounts portal. You'd use one of the login servers to access one of the scientific analysis servers, the Sci machines, where you would then have access to your home directory, and that sits on the particular type of storage called SSD storage. So it's just kind of illustrating the types of the different bits of the system that you would kind of touch by doing particular things. So then the next one talks about using one of the transfer machines, or perhaps the Globus data transfer service, which we also provide, to move data perhaps via the transfer cache into one of your into a project's group workspace, and there you can share it with your collaborators. In the middle pane, you've got perhaps a more typical thing of, you log in, you're on one of the SCI machines, you're working within your group workspace, perhaps analysing some of the data from the CEDA archive, using some of the software in the common stack of software that we provide. Perhaps you develop a workflow with scripts and code that you might develop there interactively on one of the SCI machines, but then when you've got your workflow ready and you've tested it and you're happy that it would scale up okay, you can then run it on the CPU cluster called Lotus at scale. Another really useful thing is the notebook service in the next pane. So this is a Jupyter Notebook service, which is essentially Python interactive in a browser. It's really good for visualizations and playing with code and working interactively using Python. Yeah, I think let's move on from there. So next slide. So I've talked about projects needing to sort of apply for resources for their project. So we have a system to sort of capture the requirements for particular projects. So the way we work is that the PI of the project would put in a request using a system to specify how much storage they need and the sort of start and end date of that sort of thing. And if you move to the next slide, please, Alison. We've got a kind of architecture of where a consortium manager, who's like a person who's a representative of that particular science community, organised by science discipline largely, who would be responsible for a sort of Uber allocation of the JASMIN resources of different types. So the disk storage, tape storage, maybe some of the resources that you might need for a cloud tenancy like memory and CPU and stuff. So they have a kind of overall allocation, and then a project PI would get in touch to sort of specify what their particular project would need and the timescales for that. And it's really, we delegate the kind of decision making about, what projects are important to support and what need to be sort of wound down. That's the sort of responsibility of the consortium manager. But then we as the JASMIN team act to provision those resources under instruction from the consortium manager. So that's kind of how we organise our interaction with the community on that. Okay, next slide. We also run a bunch of information services kind of jointly with CEDA, really, because we're very closely interwoven. So we have the CEDA website where we post news items of interest, and those are often also items about the service on JASMIN and the CEDA archive. There's a status page there which gives updates on current incidents and things. We have a JASMIN users email list. We have quite an extensive set of user documentation for JASMIN, covering all the different aspects of the platform, and also some discussion fora on GitHub. So lots of different ways to find out either from other users of the platform or from our own documentation about how to do stuff. Next slide. But we also run quite a few training events. Alison mentioned the sort of regular JASMIN workshop, beginners workshops that we run at regular intervals. But increasingly, there's kind of community-led events like hackathons or requests for tailored training to support particular projects or activities that are getting underway. And increasingly, a mode that we're often asked to support now is that third parties come to us asking to sort of borrow the JASMIN platform effectively to support their training events. And usually that takes the form of supplying them with training accounts. So these are kind of temporary accounts pre-configured with access to all the required things. And usually a very common thing they want to use is the Jupyter Notebook service, partly because it's just ideally suited to training. It allows people to sort of play with code and libraries and visualizations and stuff very easily. So yeah, that's one of the things we do. Let's move on. So here are some of our current priorities for things we're working on, not because you need to remember them, but just to give you a flavour of the sort of work we do. So we've just undertaken over 2 years, actually, a complete sort of storage replacement for the storage used for the CEDA archive and the group workspaces, some 60 petabytes. So that's still underway. Some of the data migration involved in that. We're developing a case for how we might, provide the GPU cluster in the future, because the old system that we currently have is in need of replacement. I mentioned environmental sustainability, so we're really looking into options of how we can do what we do with less of an impact on the environment. One example, for example, is like the storage that we've just replaced. That 60 petabytes is now solid state storage, which has about a quarter of the power draw of the previous equivalent 60 petabytes. So we're always looking for ways like that, also working with the community to look at ways that we can help them run their code more efficiently, store their data more efficiently. So we're also developing closer links with other similar digital research infrastructures, trying to expand the reach of JASMIN to other communities, not just the environmental science, perhaps some of the other communities within UKRI, which is a sort of umbrella for all the different research councils. And there's the developing UK digital research infrastructure itself, which we want to sort of ensure we're closely integrated with. So let's move on. So some of the other slides, which perhaps will help, we'll perhaps just step quickly through, just give you a flavour of the sorts of things that we cover in some of our training materials. So if we just step through these, Alison. So the first one is, we can probably skip this one. So mix of different storage types to support different types of workflow. And you don't need this detail, but it's just to give you an idea that different storage types have different features that are useful for different things. So for example, for high performance data analysis, often parallel read and write is really important. For other contexts, the ability to access that storage from everywhere is really important. So increasingly object storage, or S3, like Amazon S3 storage, we actually have some of that type of storage that we operate within JASMIN as well. So we have a mix of this different type of storage. Quite a common thing for people to want to do is to develop an application based on data analysis that they would then host in production elsewhere. So having the same sorts of things like the cloud infrastructure and the object storage and the types of things that they would be able to use in production elsewhere is a useful sort of step in that development life cycle. The next slide. This shows how we deploy our storage, so home directories and group workspaces and Scratch, and how they're mounted on certain systems within the JASMIN platform, but not all. So for example, the CEDA archive is accessible pretty much everywhere within JASMIN, but only read-only. Obviously, the only place that you can write to it would be from the archive ingest process machines, but everywhere else you can access it read-only. So next slide. I can probably skip that. Actually, no, let's just hover on the nearline data store. So it talks about nearline storage. So increasingly, the sort of environmental impact is a big thing that projects are and we are concerned about. So getting users and user projects to actively consider the impact of their workflow is really important. So offering a nearline data storage service is really important, because then it enables them to just keep online on disk those data that they need right now, and perhaps to store on lower energy nearline, basically tape-based storage, the things that they perhaps need next month, and then knowing that they can bring that back onto line for when they need it, the overall energy usage stays low. And of course, the tape is more easily scalable. It's much easier to buy more tapes in a robot than it is to add to a disk system. Next slide. I've talked a bit about group workspaces already, so perhaps skip that one. On the compute, so we provide these scientific analysis servers for the Lotus batch cluster. This is, once you've developed your code to a level where things can just run, without supervision, that's ideal to then farm out to the batch cluster where the scheduler actually works out, what jobs get run when, and decides, to manage the overall workload across the cluster. So it then preserves the resources of the interactive SCI servers for those users who are working interactively. So part of the training that we do aims to kind of educate the users about how to go about their work in this respect. So to do things in a way that enables 2,500 users to work together on a platform without treading on each other's toes. Next slide. I've mentioned the notebook service already, so yeah, it's just really good for interactive stuff. Also, it's now got the capability to work with some of the GPU features as well, so it's a nice interactive platform for sort of developing some of that code as well. Next slide. I've mentioned the common software stack that we have across the platform. So this is common to the scientific analysis servers, the notebook service, the batch cluster, and that's something that we sort of actively maintain. Next slide, and we provide the documentation on it as well. And the cloud, yeah. So the cloud platform is based on OpenStack, which is like an open source infrastructure for cloud platforms. And actually, there's now a product called Azimuth, which was developed out of the original Jasmine cloud platform, and it's essentially a sort of interactive portal interface to manage those building blocks as you compose your bespoke computing environment. So it makes the construction of your bespoke computing environment easy to achieve through a sort of web interface. And next slide. I've mentioned data transfer a little bit already. Globus is one thing that we have in our data transfer zone alongside some other services, but essentially, this all sits in a part of the network that is optimally designed to facilitate high performance data transfers. But the nice thing is that all users can benefit from this high performance from these services that we provide. Okay, next slide. I probably don't need to dwell on these too much. So we've got some services to help manage your own Jasmine account. Okay, next slide. And yeah, just the final slide really here. So further information, obviously we've got the help documentation, the workshop materials, the sort of training materials that we use in those workshops is actually self-service. So you can actually have a look at those up on GitHub. And we've got the Jasmine website, which is more of a sort of brochure for Jasmine really. There's the status with the message of the day in the terminal system as well, and also the discussion forums. And yeah, both CEDA and Jasmine, we run a help desk where we support our users through means of a sort of help desk system. Yeah, so I think I'll finish there.
That's great. Thanks very much to both of you, Matt and Alison. I think it was really interesting just to see the breadth of the services that you offer. I certainly feel like I know an awful lot more about Jasmine and CEDA now than I did when we started the session. There are a couple of questions in the chat, so I'll go to them first. I have a couple as well if there's time, but I will go to the ones in the chat first. So a question from Robert Darby, just saying at his university, which is Reading, we have a lot of climate and weather scientists who he supports with data management planning for grant applications. Often they need to specify what and how much data they will need to archive. For example, selecting model output and sometimes whether, let's see, I'm just scrolling through the chat here, sometimes whether they're eligible to use CEDA. And if so, whether there would be charges to do so. For example, if they're not NERC funded, would there be a charge to be paid? So Robert's saying he generally refers them to you to discuss these things and to obtain quotes if need be. But do you encourage those conversations at a pre-award stage? Can you say anything about your charging policy for non-NERC funded data? For example, if somebody is applying to a Horizon Europe grant and wanted to archive 10 terabytes of model output with you, what factors would inform your decision-making and approach to charging? So I will open that to both of you. I think there's a similar question for Jasmine and CEDA, so I think it's kind of open to both. And I see, Robert, you've got your camera open, so feel free to clarify if you want anything there.
Well, maybe I can start. I'm sorry, I'm not an absolute expert on our charging policies, but we do have a charging policy, certainly for NERC funded data. That's already part of the grant funding process. I think one of the key things that, because there's such a demand for our services, we're having to be a little bit more careful about what data we do accept and make sure it is fully funded to either store it and keep it online. So I would encourage you to talk to us at the earliest possible opportunity, really, when you're thinking about doing this sort of thing. Yeah, there is a charging policy. I cannot tell you exactly what the details are, but I could certainly put you in touch, Robert, with somebody who could give you more specific answers to that. If you wanted to have my email at the end of this, I'm willing to provide details on that. Sure.
That's great.
Thank
And
you.
I think
That'd
there
be
was,
useful. Thank you.
yeah, and I
Sorry.
think you had a similar one for JASMIN as well, I think.
Yeah, so it's the same kind of situation that really, being a NERC funded facility, it's primarily aimed at NERC funded work. So if your planned use of JASMIN falls outside of that, then yes, we would seek to recover some of the operational costs. It's not for generating a profit, it's just for helping to recover some of the costs for the funding that NERC has given us to provide that service. And that's generally scaled with the amount of storage that's needed. That tends to be the dominant thing, unless there's a very large compute requirement, for example, or large and complex requirements of other types. Again, yeah, it's a bit difficult to go into the details of the sort of charging model here, but yeah, the earlier that discussion can happen in advance of, project plans being drawn up, the better, really.
Just to pick up on the question, I think you also asked whether the relevant consortium manager would be the right person to approach at that stage.
Yeah, I think it's good to involve all parties, really. I mean, there should be a consortium manager. I think it's David Hassel now, and for atmospheric and atmospheric science, and Brian Lawrence, I think, for some of the sort of weather and climate type of stuff. So yeah, they will be in touch with us anyway about the level of resources that they have to support their communities. But the idea is that they have a sufficient allocation of the overall their slice of JASMIN resources, if you like, to be able to support the projects that come along to them in their discipline areas. So when there's projects that need to be charged for, that would essentially still need to come out of those allocations for that discipline area, but we would try and make sure that there's sufficient in the overall allocation to support that. But it's an iterative process that, and of course that all has to work within the overall sort of capacity resources that JASMIN has, which are refreshed sort of periodically via capital funding opportunities. Obviously, this is large and expensive hardware, so it's not the sort of thing that's very easy to add to in a piecemeal fashion. That's quite an inefficient way of doing it. So we try and buy in bulk at scale to get the best value for money on behalf of NERC, really.
That's great. Did you have any
Thank you very much.
clarifications, or is that okay, Robert?
No, that's very helpful. Thank you. Thank you very much, both of you.
Thank you. Well, I think this is one of the things we're hoping to do with these series, is also to help people to see the people behind the research infrastructures, because it is sometimes just about knowing, who do I talk to about this? How do I make sure that people ask the right questions in the right places? I think we've got a couple of minutes left, and I don't see any other questions in the chat. If anybody does want to raise their hand, please go ahead and we can give you preference to my question. But I don't see any hands, so I will go ahead and ask my question. I think it was for you, Alison. I noticed in your presentation early on, you were talking about the data management planning and the fact that you actually support that process. And I think that's a really interesting model. We don't see that happening very often, where the data storage part of it actually helps at that really early stage of the planning. And I just wondered, from your perspective, do you see this really leading to efficiencies when it comes to the point of ingest into the archive? Do you feel like the data is of a better quality? Is it happening more quickly? Do you have any sense of that?
Well, I think it certainly does help because, as Matt was explaining, we have to plan for resource. So, I mean, somebody may get funding to do a 2-year project. If they prepare a data management plan at the beginning of that 2 years, we can say, well, at that point in time, we're going to need X number of terabytes of storage to store this data. So it really does help with planning the space in our archive. Yeah, and I think it does help with efficiencies. Obviously, we can talk about data formats with people, because having stuff in the right format with the right metadata, you really want to capture that at the time that the project is running. It's no good sort of ingesting data and then 2 years down the line somebody else wants to come and use that data, but we don't have the metadata, and we it makes it much harder to reuse. So it's all of that, supporting that ongoing, like I said, the research data life cycle. So it really is about supporting that whole process. And the thing about the data stewardship wizard is that it is a model that's been adopted across all the EDS data centers, because more and more we are being asked to really act as a joint service. So work in similar ways across all the environmental data centers. So people who are accessing data, whether it's from ourselves or one of the other data centers, can do so in a similar way. So it's all subject to the NERC data policy, which does require this to be done. And so we're very much just having a unified way of doing that enables us to work better with our colleagues, so that we're all asking for the same information on the same sort of timescales. And as I say, if you've got multidisciplinary projects, some of the data may need to be stored at CEDA, for example. Some of it may go to one of the other data centers, and we're able to sort of see which data center can best help with each project. And that's actually what happens at the grant application time. People sort of say where they think they will store the data, and then a data scientist from the appropriate data center will get in touch at that stage and help to form the data management plan. So it really is at the very much of the project planning sort of stage.
That's really great to see, a very nice example, and I think something we can hopefully then promote to others to maybe replicate, because we don't see it often enough. So that's great. Well, I'm aware we're very close to the end of the time, and I know Linda just has a couple of wrap-ups. So thank you very much for the question and answer part. And actually, I think it's Al I'm going to hand over to. So back to you, Al.
Thanks, Joy. Thanks to Alison and Matt for your presentations today. I think it's really important to be able to highlight the digital research infrastructures across the UK and beyond. So we do really appreciate our guest speakers coming in every week. So thank you for giving us your time today, and for those in attendance. I'm just going to quickly share my screen to show you what we are hosting next week. So next week we have Elixir UK coming in. So they're the UK's national node of Elixir, the European Infrastructure for Bioscience Data. They're distributed research infrastructure and a collaborative network bringing together leading UK research performance organisations and the people behind them. What we will do is we will be sharing a link to the slides and the recording for this presentation. So if there are any colleagues who unfortunately weren't able to make today's session, we will be sharing that information around with you all. So thank you again for attending today. Just on us, the DCC, you can follow us across our social media channels, across Twitter, across LinkedIn and Blue Sky, as well as signing up to our DCC Associates form. That will give you information about upcoming events, International Digital Curation Conference, and especially this DRI webinar series as well. So I think if there's no more questions, I think we can end our session now. Thank you again for attending. Big thank you to Alison and to Matt, to Linda and to Joy as well, and for all of you in attendance as well. Please do keep an eye out for future events, because we have Elixir next week and we have another on fair sharing the week after.